Okay, so for expected value, we have this expression: x is the value of the outcome, while p is the probability of that outcome. So, for example, while choosing a fair die and the outcome is having 8, so it's either you have 8 or you don't have. So it's either your answer is T, which is low, or your answer is H, which is head. So in this particular one here, the random variable is equal to 0, while here the random variable is equal to 1. But in a case where we toss 2 coins at a time, so if the random variable, we can have head head, tail head, head tail, and tail tail. So in this case now, we have 2 for the head. Here we have 1. Here we also have 1. Where here we have 0. So this one and this one can be written together as head tail, making this one equal to 2. So it's going to be 2, 2, 0. So, but since we are tossing just a fair coin, just one, so it's either we have tail or we have head. So here, the occurrence of having head here is 0, whereas here is 1. But here we have 2. We have, oh, I'm sorry. Here is 1, not 2. Here is 1. It's equal to 1. Here is equal to 1. So we have 1, 2, 0. 1. Yeah. So let's quickly take an example from here. So if a fair coin is flipped once, the expected value of the random variable x given the total number of heads. So from the explanation the other time, if it's flipped once, it's that you have a tail or you have an head. So the expected value of the random variable is the number of heads you have at any instance. So if what you have is tail, that means the number of heads you have here is 0. But if what you have is head, that means the number of heads you have is 1. So for here now, the expected variable is equal to, for the first one, for the first occurrence, having a tail, that's 0. That's the value of the outcome, multiplied by the probability 1 over 2. Because the probability of this one occurring is actually 1 over 2. Plus the second one is 1, multiplied by 1 over 2, which is equal to 1 over 2. For the expected value of x when the fair coin is tossed once. So let's quickly consider what if the what if the coin is not fair. So let's consider an example that states that the probability of having an head in an unfair coin is equal to 2 over 3. So that means the probability of not having an edge will be equal to 1 over 3. So for that one, the expected value will be equal to 0 into bracket 1 over 3 plus 1 into bracket 2 over 3, which gives us 2 over 3 as the expected value. I hope you understand. So another example is to consider a fair die. So the die has 6 faces. So we can either, when we toss it, we can either have 1, 2, three, four, five, or six. Like five, six different outcomes, and the probability of each one is over six. So for that particular one, the expected value for the random variable is equal to 1 into bracket 1 over 6 plus 2 into 1 over 6 plus 3 into 1 over 6 plus 4 into 1 over 6 plus 5 into 1 over 6, then plus 6 into 1 over 6 and 6 over 6. So adding everything together gives us 21 divided by 6, which is 7 over 2. So the expected value for this is 7 divided by 2, which is 3.5. So this is because each of the 6 possible outcomes, which are 1, 2, 3, 4, 5, 6, has a probability of 1 over 6. Yeah. So another application of expected value is when we want to calculate the expectation of winning from a game of chance. So let's just take this example. Okay. In a version of Pick 3 lottery, so I'm on page 17 of the material now. A single entry ticket costs $1. So in this lottery, 3 single digits are drawn at, and the ticket must match all 3 digits in correct order to win a prize of $500. What is the expected value of one ticket in this lottery? The expected value of one ticket in this lottery. So from the explanation, we see that the probability of winning this is 1 in 1,000. That's 1 in 1,000. So that means if the probability of winning it is 1 over 1,000, winning. Probability 1 divided by 1,000. That means the probability of losing is 1 minus 1 over 1,000, which is equal to 999 divided by 1,000. Is that correct? So that means if someone buys a ticket to play the game and the ticket costs $1 and you want to win $500, so that means the net profit that the person is expecting is $499, subtracting that $1 from the $500, right? And that also means if the person is going to lose, the person is losing $1, and the chance of losing that $1 is 999 over 1,000. So the expected value that the person is going to lose at for each game is what we want to find out. So let's say the expected value is X. Will now be equal to, what is the amount that the person is going to win? The net amount. The amount is meant to be 500, but he has already spent 500 on, $1 on buying tickets. So that's that 500 minus that $1 into brackets the probability of the person winning, which is 1 over 1,000. plus what's the probability of the person losing? 999 over 1000. And how much is the person going to lose? $1. So this one is minus 1 into bracket 999 divided by 1000. So this one gives us 499 over 1000 minus 999 divided by 1000, which gives us minus 500 divided by 1000. That's minus $0.5. So that means every ticket that this person buys, he loses $0.5. So even if the person decides to buy all the 1000 tickets to try to win, at the end of the day, he's going to still get back the $500 that he invested in buying all the tickets. So that's that about it. So here now, the expected value of $0.5 in this case indicates that if one plays this lottery many times on an average, one should expect to lose 50 cents on every ticket. So that was what I said before.